Hello children, today I am here to do the revision exercise 3. This is the last exercise in your textbook. So after you complete all third term work, try to do this review exercise. We'll see what are the questions here. You get what is the number represented by this. So what are these? These are tally marks. So we know one set is 5. So how many are there? 5, 10, 15 and 2. So 5 plus 5 plus 5 plus 2. 15 plus 2, that's 17. Look at the second question. Find the value of the algebraic expression x minus 2 when x equals 14. That's substitution. Substitute x equals 14. 14 minus 2, you get 12. Write 2085 grams in grams and kilograms. So when you take 2085 grams, I can split this into 2000 grams and 85 grams. Now what is 2000 grams? You can divide by 1000 and write down in terms of kilograms. So when you divide by 1000, you get 2 kilograms, and this 85 you can write in grams. Write two ratios that are equivalent to 2 to 7. You can take any multiple. You can multiply by 2. When you multiply, you have to do for both numbers. 2 times 2, 4. 2 times 7, 14. Another one, I can multiply by 3. 3 times 2, 6. 3 times 2, 6. 3 times 7, 21. So these are equivalent ratios. If the price of 6 mangoes is 72 rupees, what is the price of 3 mangoes? So here you can use ratios here. Price of 6 mangoes ₹72. Now they are asking price of 3 mangoes. Now look at this one. How you get 3 from 6? Divided by 2. So you have to divide this by 2. So 72 divided by 2, you get 36 rupees. Find the value of this one. So what is this? These are indices. 2 to the power 3. Another name for that, 2 cube. 3 squared or 3 to the power 2. Find the value. 2 to the power 3 means 2. You multiply 3 times. 3 squared means you multiply 3 twice. So 2 times 2 times 2, you get 8. 3 times 3, 9. And now multiply 8 and 9, you get 72. Write 81 as a power of 3. So to do that, you can divide by 3 and see how many times you divide. 3 times 2, 6. And for 21, that's 7. 3 times 9. Again, divide by 3, you get 3. Again, you can divide, you get 1. So till you get 1, you can divide. So how many 3's are there? 1, 2, 3, 4. So 81, you can write 3 to the power of 4. Question number 8. The following is a net of 1 centimeter into 1 centimeter squares that can be used to make a cube. What is the area of all the faces of the cube made with this net? So if 1 is 1 square, centimeters. How many squares are there? 1, 2, 3, 4, 5, 6. So what's the area? Area is equal to 6 square centimeter because 1 square represents 1 square centimeters. A board with the word fly is shown here. If each small square is 1 centimeter into 1 centimeter, what is the total area of the letters in square centimeters? So we can count how many squares are there. If you take the F letter, we'll take this one A. 1, 2, 3, 4, 5, 6. 6 squares are there. So what's the area? Area is equal to 6 square centimeters. We'll take this one as B. 1, 2, 3, 4, 5, 6. Again 6. So the area becomes 6 square centimeters. What about the third one? 1, 2, 3, 4, 5, 6, 7. What's the area? 7 square centimeters. So we know 1 square means 1 square centimeter. Count how many squares are there. A panel of a small gate is made of wooden planks. Indicate the total length of the wooden planks used to make the gate in meters and centimeters. So here, if you take horizontal planks with 75, how many are there? 1, 2. 2 horizontal planks. We need the total length. Total length is equal to 75 centimeters times 2. We need 2 here. Plus the vertical ones are 90 centimeter long. 90 centimeter into how many are there? 1, 2, 3. 3 planks are there. So you can multiply. 2 times 75 is 150 centimeters. 90 times 3, 270 centimeters. When you add it together, you get, so 7 plus 5, 12, and 1 remaining, 3 plus 1, 4. 420 centimeters. You have to write this in meters and centimeters. So I can split this to 400 centimeters and 20 centimeters. 400 centimeters, I can divide by 100 and write down 4 meters because 100 centimeters is 1 meter. So 4 meters and 20 centimeter length. Find the perimeter of the following figure. So perimeter means outer length. So what's the perimeter here? Perimeter is equal to, how many 12s are there? 1, 2. 12 times 2. How many 2s are there? 1, 2. How many 10s are there? 1, 2, 3, 4. And how many 6s are there? 1, 2. Now add all together. So perimeter, 12 times 2, 24. 2 times 2, 4. 10 times 4, 40. 6 times 2, 12. When you add it together. So 24 and 4, 28. 28 plus 12, 40. And 40 and 40, 80 centimeters is the perimeter of this figure. This is addition and subtraction. So we'll add it. This one, we can start from right. 0 plus 5 is 5. 5 plus 7, 12. Take 1. 8 plus 4, 12. So you put 2 and take 1 here. 3 plus 3, 6. 2 plus 1, 3. 3 plus 3, 6. This one, subtraction. You can't subtract 799 from 600. So you can take 1 from there. 10 minus 9 is 1. And this becomes 9. 9 minus 9, 0. So here this becomes 5. 15 minus 7, 8. And here this is 5. 5 minus 3, that's 2. So add and see, you need to get this one. 10 and 10, again 16 and 6. So that's correct. Question number 11. It is required to prepare a mixed fruit drink for a party. 3 bottles of orange juice having 1 liter each. So 3 bottles of this. 2 bottles of pineapple juice having 1 liter each. So 2 liters. And 500 milliliters of lemon juice are mixed for this purpose. So 1. What is the amount of orange juice mixed in milliliters? So orange juice is 1 liter bottle into 3. 3 bottles are there. So 3 times 1, 3 liters. So you need to convert this to milliliters. 1000 milliliters is 1 liter. So this is 3000 milliliters. What is the amount of pineapple juice mixed in milliliters? So 2 bottles are there. So 2 into 1, that's 1 liter bottles. 2 liters. When you convert to milliliters, that's 2000 milliliters. Next part. If 4 liters of water is added to the mixture, express the total amount of mixed drink in liters and milliliters. So we'll add it. Liters, milliliters. If you take orange juice, that's 3 liters are there. Pineapple, 2 liters. And lemon, 500 milliliters. So this is 0 and this is 500. Here you can put zeros for these numbers. And water, 4 liters. So now add all together. 0, 0, 5. 3 plus 2, 5. 5 plus 4, 9. So what's the total amount of mixed drink? 9 liters and 500 milliliters. Find the ratio of the amount of orange juice to amount of pineapple juice in the mixture. Orange juice, that's we found 3 liters or 3000 milliliters. And what about the pineapple juice? We found 2 times 1000, 2000 liters. 2000 milliliters, not the liters. Now you can divide by 1000. You get 3 to 2 ratio. Next part, find the ratio of the amount of orange juice to the amount of lemon juice in the mixture. Express this ratio in the simplest form. Amount of orange juice is 2000. Pineapple is 2000. Orange juice is 3000 milliliters. And amount of lemon juice 500 milliliters. Both are in milliliters, so you can divide by 100, 30 and 5. You can divide by 5 again. 1 and 6. 5 times 6. So you get 6:1 ratio. If 38 persons participate in the party, find out whether this amount of drink is adequate to serve 250 milliliters each. So we'll see if each person gets 250 milliliters. So what's the total amount required? (38 into 250 milliliters we need. We'll multiply and see. 250 multiplied by 38. 30 and 8. 3 times 0, 3 times 5, 15. 3 times 2, 6 plus 1, 7. 8 times 0, 0. 8 times 5, 40. 4 remaining. 8 times 2, 16. 16 plus 4, 20. So altogether 9,500 milliliters. If you convert to liters and milliliters, that's 9,000 milliliters and 500 I can split. And 9,000 means, divide by 1,000, 9 liters. 9 liters and 500 milliliters required. Now we found out before, what's the total amount you get? 9 liters and 500 milliliters. So it's exactly adequate. So adequate to serve 250 milliliters each for 38 persons. So this is adequate. Question number 12. The price of a petrol liter is X rupees. If the price of a petrol liter is increased by 12 rupees, write down an expression in terms of X for the price of a petrol liter after the increase in price. So what's the new price? Price before X rupees and then 12 rupees increased. So this is in rupees. X plus 12. Write down an expression in terms of X for the balance that a person receives after purchasing a petrol liter before the increase in price by giving 200 rupees. So what's the price before increasing? That's X. So you give how many rupees? 200 rupees. So what's the balance? Balance is you give 200 rupees and you spent X rupees for petrol. So 200 minus X. A vehicle can travel Y kilometers with a petrol liter. If the vehicle travels 10 kilometers after pumping 1 petrol liter, write down the number of kilometers in terms of Y that the vehicle can travel further by using the remaining petrol. So here we have to find out the vehicle can travel further by using the remaining petrol. So they are asking number of kilometers. Number of kilometers that can travel with the remaining petrol. So if the vehicle travels 10 kilometers after pumping. So altogether can travel Y kilometers and already travel 10 kilometers. So Y minus 10 kilometers is the remaining distance. If Y equals 14, find the value of the expression obtained in 3. So what's Y minus 10? So if Y equals 14, that's 14 minus 10, you get 4 kilometers. If X equals 160, find the values of the expressions obtained in 1 and 2 separately. 1 and 2. So 1 we got X plus 12 and 200 minus X. So 1 X plus 12, that's the new price. If X equals 160, what's the new price? 172 rupees is the new price for the petrol. And the other one is 200, remaining balance 200 minus X. Balance is 200 minus X. If X equals 160, so you get balance of 40 rupees. Question number 13. A certain type of sweet is prepared by mixing the items given above and then adding water. Express the total mass of the items mixed other than water in kilograms and grams. So without water, we have to find out the total mass. Sugar 750. So I'll put kilos and grams. 750. Margarine 750. Flour 1 kilo. I'll put zeros for this. So you need the total mass. 0, 5 and 5, 10, 1 remaining. 14 plus 1, 15 and 1 remaining. 1 and 1, 2. So 2 kilos and 500 grams. This is without water. The mass of the mixture after adding water is 3 kilos and 75 grams. What is the mass of the added water? So that's the difference. So we can just subtract kilograms, grams, 3 kilos and 75. We have to put a 0 there. 0.75. And we need to subtract 2 and 500. You can't subtract here, so we need to take 1 here. 1075 minus 500. 5, 7. And 10 minus 5 is 5. So this is 0. So what's the mass of water added? 575 grams. Sudeepa says that the number of sweets made will exceed 200 if a mass of 15 grams is used from the mixture with water to prepare one sweet. Show that her statement is true. So how many sweets we can make? So what's the mass of one sweet? Mass of one sweet is 15 grams. What's the total mass? Three kilos. After adding water, 3 kilos and 75 grams. Now we can convert to grams here. 3 means 3000. 3000 plus 75, 3075 grams. So number of sweets you can make. can divide and see. 3075 divide by 15. How many sweets? We'll do long division. 15 times 2, 30. For 7, that's nothing. For 75, how many? You get 5. 5 times 5, 25. And 5 times 1, 5 plus 2, 7. So, you can make 205 sweets. So, it says exceed 200. Yes, this is greater than 200. That means the statement is true. Statement is true. The marks received by 30 students in an evaluation which carried 10 marks are given below. Represent this data in the following table by using tally marks. So, marks are there. The number of students who obtained the marks in the first column denoted by tally marks and the number of students. So, first we'll make the tally marks and then count. We can start from the left side. 3. Here. 6. 5. 7. 1. 8. 6. Here. 7. Here. So you can put a cross here. That means 5. 8. That's here. 4. That's this one. 7. 8. Here. 3. 0. You can cross out. 9. Here. 7. 2. 3. 5. 6. 5. Can cross it out. 9. Can cross it out. 7. 8. 8 is here. 10. 4. 1. 6. 7. And 6. Now we'll count 5 and 4. That's 9. 5, 5, 10, 10 plus 4, 14. And 5 plus 2, 7. So represent this data by a picture graph. We'll try to draw this 9, 14, 7. So we got 9, 14, 7. Now we have to draw a picture graph. So we'll take a picture like this, full picture worth 2. This represents 2 people. Half means 1. So how can you make 9? We need 4 of the full. 4 times 2, 8 and 1 means half. So we'll try to draw that. We'll take 4 of this. 1, 2, 3, 4, that's 8. 2 times 4, 8, and we need half of this. So we'll take half of this. So here, that's 9. Now, how can we make 14? So we need 7 of full parts. So 7 times 2, 14. So we can draw to make 14. So we'll take 7, 1, 2, 3, 4, 5, 6, and we need one more, 7. Now, how many you need to make 7? 2 times 3. 3 of the full thing and 1 part of this. So we'll take 1, 2, and 3, and half, 1 half. So you get 7 there. So here it represents 9, 14 and 7. So that's the pictograph. How many students obtain 5 marks or higher? Look at the diagram. 5 or more than means 5 also included. So that means we are adding 14 and 7. 14 plus 7, you get 21 students are there. If the students are categorized as 8 to 10 marks, reach the competency level. That means this one, 8 to 10. 5 to 7 means the second group. 5 to 7 means approaching the competency level. And 0 to 4 means the first one, direct to remedial learning. Write the number of students that belong to each category separately. So same thing given. So this is 8 to 10 means 7 students. 5 to 7, 5, 6, 7 included here. Approaching the competency level, that's 14. And 0 to 4, that means direct to remedial learning, 9 students are there. Look at this one, question number 15. If 16 is 2 to the power something or 4 to the power something, write the suitable numbers in the boxes. So how can we find out? We can divide by 2 and see how many times we need to divide. 2 times 8. Again you can divide by 2. 4. 2 and again you get 1. So how many times you divide? 1, 2, 3, 4. 4 times. So you can write this is as 2 to the power 4. So 4 comes here. How we find out how many times you can divide by 4? We can divide 16 by 4 and see. 4 times 4, 16. Divide it by again by 4, you get 1. So you can write this as 4 squared. 4 times 4, 2 times. You are multiplying. So this becomes 2. Expand 3 squared and 2 squared and find its value and multiply. So what is 3 squared? That's 3 times 3. 2 squared, 2 times 2. So now we'll multiply. 3 times 3, 9. 2 times 2, 4. 9 times 4, you get 36. Write suitable numbers in the boxes. 64. So you have to find out how many times you can divide by 2. 32. Again, you get 16. Divide by 2, 8. 2 and you get 4. Divide by 2 again, you get 1. How many times you divide? 1, 2, 3, 4, 5, 6. So that means 6 here. This is base 4. How many times you can divide 64 by 4? 4 times 1, 4. For 24, that's 6. Again, you can divide 4 times 4, 16. Divide by 4, you get 1. How many times? 3 times. So 4 to the power 3 is 64. How many times you can divide by 8? 8 times 8, 64. Again, when you divide, you get 1 twice. So you can write this is 2. Write 1024 as a power of 2. That means you can divide and see how many 2's are there. 2 times 5, 1, 2. Divide by 2. 2 times 2, 4. 5 and for 12, that's 6. Divide by 2 again. 1, 2 and for 16, that's 8. Divide by 2, 64. Divide by 2, 32, 16, 8, 4, 2 and 1. How many 2's you are getting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can write 2 to the power 10. Power of 4. Now we'll divide by 4 and see. 1024 divide by 4. 4 times 2, 8. For 22, that's 5. For 24, that's 6. Divide by 4. 4 times 6, 24 and 4. Again, divide by 4. 1. For 24, that's 6. Divide by 4. You get 4 here. Again, 1. How many times? 1, 2, 3, 4, 5. So 1024 is 4 to the power 5. Find the larger number from 2 to the power 6 and 6 squared and 6 squared. So here 2 to the power 6 we did. So we can find out what is 2 to the power 6. 2 times 2 times 2 times 2. What's the number? 4, 8, 16, 32, 64. 6 squared, 6 times 6. 36. Which one is larger? 64 is bigger. So find the larger number. Larger number is 2 to the power 6. Look at this question. The results that were obtained when a cubic die was thrown 15 times are shown in the following figure. Express the number of occurrences of the numbers of each of the following types as a fraction of the total number of occurrences. Even numbers. We need to find out how many even numbers are there. So when you take a die, what are the numbers you get? 1, 2, 3, 4, 5, 6. What are the even numbers you can get? 2, 4, 6. Now see, how many are there? 1. This is 6. 2, 3, 4, 5, 6, 7, 8. 8 occurrences out of altogether 15 occurrences are there. So 8 over 15 as a fraction. Odd numbers. What are the odd numbers you can get? 1, 3, 5. So what are the possibilities? 1, 2, 3, 4, 5, 6, 7. 7 occurrences out of 15. And what are prime numbers? 2, 3, 5. Those are the prime numbers when you take a die. 1 to 6. So 2, 3, 5. What are the possibilities? 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 15. Again, we'll check 2, 3, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possibilities are there. 9 possibilities are there out of 15. Here you can simplify, but you don't need to simplify now. Composite numbers. What are composite numbers? Numbers that are not prime. But we don't take 1 as the composite number. So there are factors more than 2. So 4, 6, those are composite numbers we can take. So 4 and 6. 1, 2, 3, 4. 4 occurrences out of 15. 4 out of 15. Triangular numbers. What are triangular numbers? 1, 3, 6. 1, 3, 6. Count how many? 1, 3, 6. 1, 2, 3. 4, 5, 6, 7. 7 occurrences out of 15. Square numbers. What are square numbers? 1. 2 squared is 4. 3 squared is 9. So only 1 and 4. 1, 2, 3, 4. 4 occurrences out of 15. The fractions relevant to which two types of numbers when added results in the sum is 14 over 15. We'll see how you get 14 as the numerator. 1, 7 is there. That's triangular numbers. And 7. 7 and 7 odd numbers and triangular numbers. You can say 7 over 15 plus 7 over 15. That's odd numbers and triangular numbers. Show that the fraction resulting from subtracting the fraction relevant to the composite numbers from the fraction relevant to the odd numbers is equivalent to 14 over 15. So, fraction resulting from subtracting the fraction relevant to composite number from fraction related to odd and composite one. So, we'll see. So, odd minus composite. We'll find out what's the odd one. Odd one is 7 over 15. Composite one is 4 over 15. 7 over 15 minus 4 over 15. You get 7 minus 4, 3. 3 over 15. We can simplify and write down 1 over 5. Divide both the numerator and the denominator by 3. You get 1 over 5. Is it equivalent to 14 over 15? It's not equivalent. So, you can write this is not equivalent to 14 over 15. So, we can write not equivalent. So, we completed all the chapters and all revision exercises in your textbook for grade 6. So, practice all these and we'll meet you in the next grade. So, I hope that you will join with me to study grade 7 mathematics.